Precalculus. This is question number 6 from the Chapter 7 review. It says solve the following, give all solutions on the range 0 to 4 pi. So we just have to be careful here. 4 pi includes 2 rotations. So if we were considering, just to consider the domain first. I can do it in pink because it's sort of, if we're saying theta has to be between 0 to 4 pi, that means 2 theta we would initially need to solve for 0 to 8 pi. And then when we divide through by 2, we would get it within the correct range to make sure we consider all solutions. So with that in mind, I'm going to write 2 cosine 2 theta sine theta equals cosine 2 theta. Here, seems like we have a common factor, so I'm going to subtract it over to the same side and factor out a cosine 2 theta. So we'll have 2 sine theta minus 1 equals 0. Using the zero product rule, I get 2 possibilities. Cosine 2 theta equals 0, or 2 sine theta minus 1 equals 0. Which in this case means sine theta equals 1/2. And in this case, we'll look at how we're going to answer each of these. So looking at the left side, sine theta equaling 1/2, and theta being between 0 to 4 pi would give me several values. So 1/2 is pi over 6. It is also 5 pi over 6. But then, since I can go another rotation, from 12 pi over 6, I can go 13 pi over 6. 13 pi over 6, so if that's 12, 18 pi over 6 minus 1 would be 17 pi over 6. So those would be all 4 values for which sine theta equals 1/2 for 2 complete rotations. On this hand, though, for 2 theta, we can, here, maybe just to make sure we're clear as to what we're solving for here, I will move this over to the side a bit, and I'm going to make sure we know that this is what theta could be. On this side, however, I'm writing initially for values of 2 theta. Where could cosine 2 theta equal 0? Well, and I need to remember that I need to include 4 complete revolutions because I'm going to have it. So cosine is 0 at pi over 2, 3 pi over 2. Oh, I'm going to run out of room here. So pi over 2, 3 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 9 pi over 2, 10 pi over 2, and I just need to be within 8 pi. So far I'm at 5 pi, not 10, I'm sorry, 11 pi over 2, where it's sort of every odd multiple. 11, 12, 13 pi over 2, 15 pi over 2, and I can't go further because 16 pi over 2 is 8 pi. So those are the values for 2 theta, which means theta as a whole. Now, our solution set would be half of each of those. So I'm trying to see if I can get these in order. But I'm going to go pi over 4, because I'm dividing by 2. Pi over 6 would be the first one. Sorry, pi over 6. Pi over 4. 5 pi over 6. 3 pi over 2. 5 pi over 6, sorry. 3 pi over 2. 3 pi over 2 is not a solution. 3 pi over 4 is. I'm going to find a better way to collect all these answers so I don't lose track. And I might not try and order them. I'm just going to write them out here. Here I need to divide each of those values by 2. So I have pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, 9 pi over 4, 11 pi over 4, 13 pi over 4, 15 pi over 4, oops, pi over 4, and then I have pi over 6, 5 pi over 6, 13 pi over 6, and 17 pi over 6. Okay, we're going to check this on Desmos, because that's an awful lot of values. So we have, oh, let's see, let me move this over just a bit. So I usually have it queued up right here. 2 cosine, and I need to shorten this window a little bit. There you go. 2 cosine 2 theta sine theta equals cosine 2 theta. Oh, I need to put a product symbol here maybe. Put this in parentheses, I believe, and this in parentheses too. Oh, and I meant to do this, but it looks like my little increments are in terms of pi over 4, so let's check a couple of these if I'm going from 0 to 8 pi. So here I might actually have it go from every, to catch both, maybe I can say pi over 12 here. This might not be a good idea, but let's see. And I want to go from 0 to 4 pi. Okay. Oops. And I zoomed out immediately after that. 0 to 4 pi. Okay. So, I'll just look at it myself. From here to here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values. 4, and it looks like we have 12 now. We'll have to zoom in a bit to see we got the correct values here. I got a pi over 6 is my smallest value, pi over 4, then we skip for a while, 3 pi over 4, 5 pi over 6. I remember writing those down, 5 pi over 4, 7 pi over 4. Okay. I'm hoping we've got all the correct values, but I don't know if it's necessarily worth your time for me scrolling through this. Okay. 7 minutes. I think, okay, we're going to pause this video and do part B in a different video.